Hi, welcome back. Once again, I am welcoming you all to this beautiful online learning platform, Unacademy. Unacademy is the India's largest online learning platform. Now, we are happy to announce that Unacademy is going to providing online training for GATE and engineering service examinations. About myself, I G Venkata. I have 16 plus years of teaching experience. So far, I mentored more than 60,000 students for their GATE examination. And at present I am pursuing PhD from JNTU Kakinada, and my specialization is VLSI design. First we check how to get Unacademy learning app into our device. Just go to Play Store, type Unacademy, and after that you get the Unacademy learning app like this. Now just click on this install button. Click on this install button. By clicking on this install button, it will install the Unacademy learning app into your device. Now here are the few of the top educators from Unacademy. Tiwari sir, he is the IIT topper. Ankit Goyal sir, he obtained All India first rank twice in electrical, and he was awarded President of India Gold Medal in IIT Indore. Sanchit Jain sir, he has more than 8 years of teaching experience, and he has a very sound experience in teaching students. Jaspal Singh sir, he is the ex-IAS officer. He got All India 4th rank in that, and he is the ex-senior faculty from MADESE. Now here are the few more top educators from Unacademy for different departments. Now there is a scholarship test of worth 1.8 crores is going to be conducted in Unacademy. Next, a few more scholarship tests are going to be coming. Okay, now in that test, if you get a top 3 position, then you will get 100% free scholarship on plus subscription. Okay, and for top 100 winners, you get the additional discounts. Now there is a engineering service exam ESE 2021 test series is going on for different departments. Mechanical engineering, electrical engineering, civil engineering, electronics and communication engineering departments. Now for mechanical engineering, it is on 22nd and 29th, for electrical 23rd and 30th, civil 24th and 30th March, and electronics and communication 25th March. And general studies is on 26th March. Now in that 10 questions, 20 minutes of time. It was curated by best educators. All India live ranking is provided if test is taken live, and it is designed as per the changing demand for engineering service exam. Sorry. Now there is a full length mock test also available on 21st and 28th of March at 10 AM. In that 150 questions and 180 minutes of time. It was curated by best educators. All India live ranking is provided if test is taken live, and it is designed as per the changing demand for engineering service exam. This is for mechanical engineering, electrical engineering, electronics and communication, and civil engineering departments. Now there is a golden opportunity for civil engineering students. Crack engineering service exam with Jaspal Singh sir. Join us for free test series. Free test series. These are the different topics in that. Now each topic wise exam is conducting here. For soils 6th March, and if you take SOM RCC steel, it is 1st of May, like that, topic wise. So this is the golden opportunity for the students of civil engineering students. Now there is a ultimate 10 SSC series is going on. For mechanical engineering students, the dates are 1st May, 1st March, 4th, 9th, 12th and 17th, and in that 10 questions and 20 minutes of time for that, it was conducted at 10 AM, and you can take the test can be attempted even after the live test session also. Even after the live test session also you can take the test. Now this is for mechanical electrical engineering. 10 questions, 20 minutes of time. These are the dates. Timing is same 10 a.m. After live session also you can take the test. Now same ultimate 10 for civil engineering students. 10 questions, 20 minutes of time. 3rd March, 8th March, 11th, 16th and 19th of March. Timing is at 10 a.m. Okay. And don't forget to use my code VRAU10 to take the test. You can attempt the test even after live session is completed. Now just kickstart your GATE 2020 preparation. Here also 10 questions and 20 minutes for every Tuesday, Thursday and Saturday. Okay, at 10 a.m. So my dear students, this is very really golden opportunity to this department: mechanical, electrical, computer science, civil engineering, chemical engineering, electronics and communication and civil engineering students. See this, that means here you are taking 10 questions every Tuesday, Thursday and Saturday at 10 a.m. So weekly 3 days, 3 into 10, 30 questions every week you are getting. Per month, worst case you are getting 120 questions. So 120 questions you are taking every month. See, these are prepared by, curated by best educators. Now, if you take worst case 10 months, 10 into 120, 1200 questions you are going to be getting finally. So 1200 model questions you are going to be preparing for your GATE examination. So that is more than enough to get a good rank in that. Okay, so my dear students, please don't miss this opportunity. Okay, and don't forget to use my code VRAU10 during subscription. Now we are happy to announce that recently we started 2 new batches for GATE. One for GATE 2023, other one is for GATE 2022. There is a Ascend batch for GATE 2023 Mechanical Engineering. It was started from 22nd February 2021, and it is the team. These are the team of faculty who are handling the subjects in that, and the same faculty are going to handling the subjects for GATE 2022 also. It was started from 22nd February 2021, same faculty, and there is a mission DDR going on for mechanical engineering students. This is for mechanical engineering students, mission DDR, under the supervision of Tiwari sir, Umeshwara sir, Meenu Gupta ma'am and Amanraj sir. And this batch is started with the intention that every student in this batch has to get a good rank. With that intention we started this batch, and this batch started from 22nd February 2021, and don't forget to use my code VRAU10 during subscription. Now there is a Spark batch for GATE 2022 civil engineering started. It is only English batch, and it was started from 22nd February 2021. Okay, don't forget to use my code VRAU10 during subscription. And there is a Ascend batch for GATE 2023 is going on for civil engineering. This is the team. Now in this team Jaspal Singh sir is there and Gil sir is there. Okay, so everyone is a top educator, top faculty educator and experienced faculty. Okay, so this batch started from 8th February 2020. Same team is going to handling the subjects for GATE 2022 also for civil engineering. Same team. It was started from 8th February 2021. Next, there is a Evolve batch for GATE 2022 for computer science and information technology. So Ravindra Babu sir, Sanchit Jain sir, Subbarao sir, Malisham sir, sorry, Sweta Kumari ma'am, Vishwadeep sir. These are the top educators and faculty working under this. And Ravindra Babu sir is the alumni of IIC Bangalore, and he is the first faculty who started online training for computer science students. And there is a Ascend batch for electrical engineering for GATE 2023. It was started from 1st February 2021. For electrical engineering, this is, see, the team is large team. That means a more number of subjects is there in electrical. That's why the team is lengthy one. Next, we move to GATE 2022. There is a all batch for GATE 2022. And the same team is handling the subjects in that. It was started from 1st February 2021. Now we are moving to electronics and communication engineering. There is a ascend batch for GATE 2023. This is the team of faculty members who are handling the subjects in this. This batch was started from 1st February. And the same team is going to handling the subjects for eval batch for electronics and communication for GATE 2022. This was also started from 1st February 2021. Last but not least, now we are moving to chemical engineering. So there is a eval batch going on for chemical engineering for GATE 2022. Okay, and this batch was started from 25th January 2021. And here are the team of faculty members who are working under this. Okay, and throughout India, according to my knowledge, throughout India, hardly 1 or 2 locations only training for chemical engineering is available. So now there is no need to move anywhere from your location. Just by staying at your home itself, staying your own place itself, just by online, you can complete your GATE training. Okay, in Unacademy. Now, just I glance different engineering departments available in Unacademy for GATE and engineering service examinations. Electronics and communication engineering, chemical engineering, computer science and IT department, instrumentation engineering, electrical engineering, civil engineering, production and industrial engineering. Okay, and mechanical engineering. These are the different engineering disciplines available in Unacademy for GATE and engineering service examinations. Now, there are 2 subscriptions, the plus subscription and iconic subscription. Plus subscription is the basic plan. Iconic is take your GATE engineering service preparation to the next level with personal coach. In plus subscription, India's best educators are handling your subjects. Here also same. Interactive live classes is there. Structured courses and PDFs. Live tests and quizzes. Here also live tests and quizzes. Now, in this live tests and quizzes, here whoever the personal coach we allotted to each and every student, that personal coach is going to perform the personalized test analysis. Whatever the test you was written, the test is going to be analyzed by that personal coach, and they will note the important points on that. That means where you are strong, where you need preparation, where you are doing mistakes, okay, where you are where you need much preparation, where you are cutting confusion, everything they will prepare a note. Based on that, they will prepare a proper study planner to you. Study planner, the study planner is, if you compare this cost, for example, you joined outside for taking offline training somewhere, so you have to attend the classes during weekends and in public holidays. In that time, for transport from your home to the training location, minimum of you need to spend throughout year 20,000 plus. Just by adding a little bit amount to that, you can complete the training, GATE training, by staying at your home itself. No need to move anywhere. Just by staying at your home itself, you can complete the preparation, complete the training as well as preparation. And whatever the transport time you are spending daily 2 hours for transport time, you can spend the transport time for your preparation. That is the benefits here. And one more important thing, here your classes are taken care by the India's best educators. Okay, next, there is an iconic plan. In these two subscriptions are there, 1 year subscription and 2 year subscriptions. For 1 year subscription, it is 50,250 rupees. By using my code VRAO10 during subscription, you get it by 45,225 rupees only. And this amount is more or less close to the amount what you have to pay at outside offline institutions for training. With this amount only, we are providing personal coach also to you. With this amount only, we are providing personal coach also to you. Okay. And one more thing, some of the institutions outside, they are charging 1.5 times, 1.6 times of this amount. With the less amount, you are getting all India's best educators classes, and no need to move anywhere, and outside situation is not good. No need to move anywhere, just by staying at your home itself, just by staying at your room itself. Okay, you can complete your GATE training. Okay, so my dear students, please think once of it and take a right decision. That decision has to change your lives in a good direction. Thank you. Thanks for spending time. Now we are moving to our today's topic, MOSFET. Already some portion of MOSFET we completed in previous sessions. Okay, now I'm going to reviewing glance that just slide by slide. First we done the classification of MOSFET. After that, construction of E-MOSFET. Next, channel formation or inversion. These are the characteristics. Variation of channel with respect to VDS. This is the output or drain characteristics. MOS capacitance or gate capacitance. IV relation. Here we derived IV relation. Channel length modulation. This is IV relation. IV at different conditions, and these are the next regions of operation at different regions of operation. Equation for IDS. This is the equation for IDS in saturation region. This is IDS in saturation region. Next applications, it can be used as a switch and amplifier and voltage dependent resistor. These are the symbols for MOSFET. Channel length modulation. Already we completed all these things in previous sessions. So due to channel length modulation, drain current is increasing, IDS increases. So far we completed up to this topic. Now I am going to representing CMOS, latch up in CMOS. There is a concept we called, previously there we defined in MOS technology, MOS transistor, we shorted source and substrate. Okay, and there we mentioned to solve the problem of body effect. First of all, what is body effect? Okay, how it came to picture. So to understand that, first you should know the CMOS transistor, CMOS technology. The basic CMOS is the Cmos inverter. Okay, CMOS means complementary MOS. Okay, complementary metal oxide semiconductor. Now if you take this Cmos inverter, it is like this. Here we have a pull up device. Here we have a pull down device. This is PMOS. Both are enhancement devices. And this is NMOS. Here we are applying input. This is VDD and this is VSS. And this is the source. Here it is the source. Okay. And here taking the output. Taking the output. This is the Cmos inverter. Cmos not gate. Okay. Now, the purpose of switching from regular MOS transistors to Cmos is, in a regular MOS technology, once transistor is on state, see this is the NMOS inverter. NMOS inverter. Here is a depletion MOSFET we are taking. Depletion MOSFET taking. Here is enhancement. Here applying input, taking output here. It is VDD. Now the gate is connected to this. Okay, gate is connected to this. Once it is connected to this, it behaves like a resistor. Okay, resistor. So once it is resistor, if input is high, this NMOS is on state. Let us take it as Q. If Vin is high logic, then Q is on state. Once Q is on state, your output is equals to low. At that time, there is a current flow from supply to ground. Ground can also call it supply, VSS. Now there is a static current flow from VDD to ground, VDD to supply, VSS. Due to this static current flow, power dissipation takes place in that. So high power is dissipating in that. Okay, so that is the drawback in that. But if you move to this CMOS inverter, if I take input is high, let us take it is a QP PMOS transistor and it is NMOS transistor. Here is QP and here is QN. It is input. If input is high and next take input is low. If input is high, QN is on and QP is off. QN is on. And input is low, QP is on and QN is off. In this case, output is low, connected to ground. It is low. In this case, output is high, because once it is on state, your output is connected to supply through this QP, and once it QN is on state, your output is connected to ground like this. So at a static conditions, at a time two transistors are not on state. Simultaneously QN and QP are not in conduction. So there is no static current flow, but only dynamic power dissipation is there. Okay, dynamic power dissipation is there. So this is the advantage of CMOS inverter. So power dissipation is less in CMOS inverter compared to NMOS inverter. Okay, that's why we are going to giving high priority to CMOS technology. Now almost in all ICs are designed by using CMOS technology. CMOS NAND gate, NOR gate, whatever the logic you want, you can realize that logic by using CMOS transistors. Okay, CMOS technology. Now I am going to writing the Cmos transistor internal structure can be designed by using N-tap process or N-well process or P-well process. Now here I am taking, that means in this you have one PMOS transistor and one NMOS transistor. So now the CMOS transistor is like this. So here I am drawing this. Let us take it as a lightly doped N-type semiconductor. Lightly doped N-type semiconductor. That means we can use this one to form PMOS transistor. PMOS transistor. That means now I want to get a NMOS. To get the NMOS, you need to go for P substrate. So here at this end I am going to P substrate. This end I am going to P substrate. P substrate. Here. Here is P substrate. Now this is lightly doped P-type semiconductor. It is lightly doped P-type semiconductor. Now here at this end, now here you are going to getting PMOS, here you are getting NMOS. Now first I am going to completing the NMOS. So there is a diffusion here, N plus diffusion. N plus diffusion and N plus diffusion. So here also it is a P plus diffusion. Now here it is P plus is N plus and it is a P plus and it is N plus. So upon this we are going to placing oxide layer. I am going to placing oxide layer upon this. Here also oxide layer I am placing. Upon this oxide layer, metal we are placing. Metal I am placing. Yeah. Now, this is the gates. This is the gate. This is the gate terminal. Now, these two gates are going to be connected. This is our circuit diagram. This is our circuit diagram. This is Cmos inverter. This is our Cmos inverter. Vi input. This is VDD. it is VSS. Okay, now this is NMOS, this is PMOS. So NMOS, source connected to ground. So this is the source. I'm going to connecting the source to ground. Source connecting to ground. Source connecting to ground. So this is source connecting to ground. Now this is going to be the drain. Drain connected, drain of PMOS connected to VDD. Drain of PMOS connected to VDD. Drain of PMOS connected to VDD. Okay. Next. Sorry. Source of PMOS. Sorry, this is source of PMOS. Source of PMOS connected to VDD. And drain, source of NMOS connected to ground. Source of PMOS connected to VDD. Now both the gates are shorted and connecting input to that. Input. And taking output by connecting both the drains. Both the drains are connected and taking the output. This is the Cmos gate, Cmos inverter. Now what we have, what is the problem is here it behaves like a substrate to this and it behaves like a substrate to this. Now see carefully, this is P, this is N, lightly doped N type, and it is the 2P plus, and it is P. So PNP, there is a chance of forming PNP transistor. A self-sustaining it is a self-sustained unwanted parasitic components are forming internally in the device. Our intention is not to create that, but our intention is to create CMOS. But in that process, a parasitic component is forming internally. So it creates PNP transistor and the substrate. So now I am going to drawing the transistor symbol PNP. So it is base. So let us take it is emitter. Emitter. Base. And it is collector. It is collector. Now at the same time, whatever the substrate here we have, that substrate impedance can be resistance or conductance can be represented by a resistor. Substrate resistance Rn. Next. So this. So this is base. Here is collector. Here is collector. So this is P plus. Next. Now this is going to provide some resistance. Rn, resistance of this substrate. Okay, once a sufficient current flowing through the substrate, now the drop across Rn is going to make this transistor of PNP into on state. Make the transistor into on state. Next, same. This is okay. See this N P and this is N. Here it is N plus P N. So a transistor is like this. Now this is it is acting as a base N P N N P N. So it is acting as a base. So it is N plus. So it is acting as a emitter. This is the direction of current. It is collector. It is base. So this is P minus. It is also P type material. So both are same. Both are the substrates of NMOS. Here N channel substrate. Sorry, NMOS substrate. Now this one and this one both are representing the same thing. Now both are representing the same thing. And one more thing. Whatever the substrate, here we have P minus substrate in NMOS substrate, that is going to be represented by a resistance R N RP. Now see, once sufficient current initial, so we are expecting in this CMOS, what we are expecting is a controllable current flow should flow through this. That too, that current should flow through the channel. That current should flow through the channel. That is what we are expecting. Current should flow through the channel. But due to these parasitic components which are present in this, there is a chance of current flowing through this. This is the low resistance path compared to this channel. If a sufficient current is flowing through this resistance Rn, then this transistor is going to be on state. Once it is on state, now current is flowing through this resistor Rp. Now if a sufficient current is flowing through this resistor also, then this transistor NPN also going to be on state. Now once both are on state, now there is a current flow from drain to source like this. Okay, this is the low resistance path. This is due to the parasitic components which are present within the device, within this structure. Okay, we need to avoid it. This is called a current flow due to these parasitic components is called latch up. It is called latch up. Okay, now I'm going to writing this. What is latch up? See here. Latch up is a condition in which a low resistance self sustaining path is created inside inside substrate, inside substrate due to parasitic components, components components through which undesired current flows from VDD to VSS. So latch-up is a condition in which a low resistance self-sustaining path is created inside substrate. Inside substrate due to parasitic components through which undesired current flows from VDD to VSS. Okay. See, if this current flow is increasing, if this current flow increases, then what happens is power dissipation in the device is going to be increases. If this current flows increases, power dissipation increases in the device increases. Okay, and if this current is flowing for a longer time, then your device is going to be damaged. And if this current flows for a longer time, then the device gets damaged. So for that, what we have to do is we need to keep always this junction should be off state, this transistor should be off state. To keep this one off state, substrate and source both should be operated at different potentials, and that too substrate of n channel is a p-type material should be connected to negative potential, and this source or drain is going to be connected to, source is connected to, in case of this source connected to positive potential, and in case of this it is connected to negative potential. So to prevent latch up, substrate and source regions are maintained at different potentials, such that the junction between source and substrate should be such that the junction between source and substrate should be in reverse bias. In reverse bias. Like that you need like this you need to bias your CMOS. In that case, always this transistor is going to be off state. Once it is off state, so no chance of current flowing through the low path. That means low conducting path through unwanted directions. Only current is flowing through channel only. If current is flowing through this, power dissipation is increasing. The advantage in CMOS is power dissipation is very low power dissipation, no static power dissipation. There is no static current flow between VDD and VSS. But if current is flowing through this, both the transistors are if on state, now current is flowing like this. That is the latch-up problem. And to solve that, this one, whatever this junction is going to be, substrate and source junction should be always reverse bias. If it is always reverse bias, this parasitic transistor is always off state. Once it is off state, there is no current flow in that. This is the concept latch-up. Okay, now this latch-up is going to be indirectly related to the concept of body effect. Okay, so what is that body effect and everything we discuss in the next sessions. Thank you. Thanks for spending your valuable time with us, and don't forget to use my code VRAO10 during subscription. Subscribe us, and please give your valuable comments on us, and don't forget to click on bell icon for getting notifications, and please join our Telegram group for getting latest updates on our upcoming videos. Thank you. Thank you very much. And once again, I am welcoming you all to this beautiful online learning platform, Unacademy. Thank you very much.